Okay, looking at number 1. So on the test, you're going to need 4 points for your graph. So we're going to plug in points for x and get points for y. So our points that are the easiest to plug in for x are going to be -1, 0, 1, and 2. So we're going to plug those in where our x is. So we have 5 times 2 raised to the -1. That is 5 times 1/2, because when you have a number raised to a negative, it becomes a fraction, and that number goes in the bottom. So this is 5/2. If we want to change 5/2 into a decimal, we can. And we know that's 2.5. It just helps us see it on our graph a little bit better. So we're going to go to the left 1 and up 2.5. So our first point is going to be right there. Next, we're going to plug in 0. So we have 5 times 2 raised to the 0. Anything raised to the 0 is 1. So this is 5 times 1, which is 5. So if we go to our graph, we stay on 0 and go up 5. Next, we're going to plug in 1. So we have 5 times 2 to the first power. This is 5 times 2, which is 10. So we're going to go to the right 1 and up 10. And then our last point we're going to plug in is 2. So we have 5 times 2 squared. 5 times 2 squared is 4. So we have 5 times 4, which is 20. So our last point is 220. So we're going to go to the right 2 and up 20. So now that we have our 4 points on the graph, our graph is going to look like this. Remember, it's important here that our exponential graph never crosses the x-axis. So it's never going to go over this line. So just be aware of that when graphing it on the test. Okay, let's look at our second graph. So here we know, since this is less than 1, we're going to have an exponential decay graph. So again, we're going to plug in our 4 points for x, and we're going to get some points for y. So we're going to plug in -1, 0, 1, and 2. So first we have 3 times 1/2 raised to the -1 power. That -1 flips our fraction. So we have 3 times 2, which is 6. So we're going to go to the left 1 and up 6. Next, we're going to plug in 0. So we have 3 times 1/2 raised to the power of 0. This is 3 times anything raised to the 0 is 1. So 3 times 1 gives us 3. So we're going to stay on 0 and go up 3. And then next we have 3 times 1/2 raised to the first power, which is 3 times 1/2, which is 3/2. If we want, we can change this into a decimal, just so we can see it better on our graph. So this would be 1.5. So we're going to go to the right 1 and up 1.5, which is about there. And then next, we're going to plug in 2. So we have 3 times 1/2 squared, which is 3 times 1 to the 4th, which is 3/4, which again, we can change this to a decimal and make it 0.75. So on our graph, we're going to go to the right 2 and up 0.75, which is about there. Now it's important here when drawing our line that we don't cross the x-axis. We just get really close to it. Okay, so that's our graph number 2. Next, for our word problem on the test, we're using this formula. So not the compounded continuously, but just our regular interest rate formula. So we have a times 1 plus r raised to the t. So we need our A, our R, and our T. Our A is our starting amount. So in the first year, there were 500 people. So our starting amount is 500. The attendance increases by 22%, so our rate is 0.22. And then it's asking us for how many people there be in the 5th year, so our time is 5. So we're just going to plug everything into our formula. So we have 500 times 1 plus 0.22 raised to the 10th power. I'm sorry, this is raised to the 5th power, because our time was 5. So we have to add what's in our parentheses first. So 1.22 raised to the 5th power. And now we're going to put that into our calculator. So we click that 1.22, x raised to the y, then 5, then equals, and we get 2.7027. And then we just multiply this times 500. And we get 1,351. Okay, next for number 4, we're going to use that same formula. So we need our A, our R, and our T. Our A is our starting amount, so 37,000. Then our rate is our percent, but we need to change it to a decimal. So here, it's important that we move our decimal 2 places when changing percent to a decimal. So this becomes 0.03. And then our time is 10. So we just plug everything in. We have 37,000 times 1 plus our rate, which is 0.03, raised to the power of 10. 37,000. We add what's in our parentheses first, so 1.03 raised to the power of 10. Now we put 1.03 into our calculator. We click that x raised to the y, then 10, then equals, and we get 37,000 times 1.3439, and then multiply those two together. And our final amount is 49,725. Okay, and on the test, there's going to be one question from the graphing section and one word problem. We need to rewrite each equation in exponential form. So our base comes out of the basement. So we have 2. Then we write our answer. Then we write what's on the other side of the equal sign as our exponent. So 2 raised to the negative 2 is equal to 1/4. Number 6, our base. Remember, if a base isn't written, then that means our base is 10. Raised to what's on the other side of the equal sign, which is 0, is equal to 1. Number 7, our base comes out of the basement, then our exponents on the other side of the equals, which is 1, so 15 raised to the power of 1 is equal to 15. And then number 8, our base comes out of the basement, which is 14. Our exponents on the other side of the equals, which is 2, and then that's equal to 196. Any questions on this part? All right, number 9. Rewrite each equation in logarithmic form. So we're doing the same thing that we did up top, but in reverse. So our base goes into the basement, so log base 16. Next we write our answer, which is 256, and then that's equal to our exponent, which is 2. Number 10, we write our log, base goes into the basement, then we write our answer, 196, and that's equal to our exponent, which is 2. Number 11, our base goes into the basement, so log of 324. Then we write our answer, which is 18, and then it equals our exponent, 1/2. And then number 12, our base goes into the basement. Then we write our answer. And then that's equal to our exponent, which is 5. Any questions on this part? All right, number 13. We need to evaluate each expression. So it helps when we write this in exponential form. So we can say 4 raised to the x is equal to 16. And we know that 4 squared is equal to 16. So x is going to be equal to 2. Next, number 14, we're going to say 7 raised to the x is equal to 343. 7 raised to the third power is 343. So 7 raised to the third power is 343. So we know that x is equal to 3. Number 15, 2 raised to the x is equal to 64. Let's see, if we have 2 squared, that would be 4. 2 cubed would be 8. 2 to the 4th power would be 16. 2 to the 5th power would be 32. And 2 to the 6th power would be 64. So 2 to the 6th power is equal to 64. So x has to equal 6. Any questions? Are you guys still here?
Yes.
Okay, good. Let's go to 16. So we have 7 raised to the x is equal to 49. And we know that 7 squared is equal to 49. So x has to equal 2. Okay, so on this page, on the test tomorrow, I think there's going to be 2 questions from each of these sections. And then on the first page, there's going to be 1 graphing and 1 word problem. Okay. So now we need to condense each expression into a single logarithm. So for these questions on the test, you're not going to be solving anything. All we're doing is condensing it into a single logarithm. So we're just going to have one single log and then just one term. That's it. All we're having is one log. We're condensing it into one. So the first thing we need to do is bring our exponents to the top. So we have log base 8 of 10 raised to the 4th power minus log base 8 of 7 raised to the 24th power. And then since we're subtracting here, that means we need to divide them, and the first one goes on top. So we're going to have log base 8 of 10 to the 4th power over 7 to the 24th power. So here, if you notice, we only have one log, and then all of our terms come after it. Any questions on this one? All right, that's good.
That kicked me out, sorry.
No problem. Do you get 17?
Yes.
Okay, let's go to 18. So here we need to move our exponents to the top. The only one that's going to have an exponent is this last one. So we have log base 8u plus log base 8v plus log base 8w raised to the 3rd power. And now since we're adding all the terms, that means we multiply them. So we're going to have one single log All right, let's go to 19. Okay, so our exponents are going to go to the top. Here, when it's divided by 2, this is the same thing as saying, so I'm just going to rewrite this here. It's the same thing as saying 1/2 times log base 3 of 7. So our exponent here is this 1/2 that we're going to bring to the top. So we have log base 3 of 11 to the 5th power plus log base 3 of 7 to the 1/2 power, but we know that something to the 1/2 power is the square root, so I'm just going to write the square root. And now since we're adding them, we just multiply them together. So we're going to have one single log base 3, 11 to the 5th power times the square root of 7. Any questions here? All right, let's go to 20. So we're going to move our exponents to the top. So we have log base 6 x to the 6th power minus log base 6 y to the 5th power. And since we're subtracting, that means we're going to divide. So we're going to have one single log base 6. The first one goes on top, and then the second one goes on the bottom. So x to the 6th power divided by y to the 5th power. This is our answer. Any questions here? So no questions from this group? For the condensing and the expanding, there's going to be 2 questions on each of those 2. Okay, next we're expanding the logarithm. So here we see that in here we're multiplying. So that means we're going to break it up and add them. So we have log base 7 of w to the 4th power plus log base 7 of the square root of u. So every time we break something up, everything needs its own log. So now we're going to move our exponents to the front. So we have 4 log of 7w plus this square root is the same thing as saying raised to the 1/2, so we're going to bring a 1/2 to the front times log base 7 of u. Any questions here? All right, 22. So here we have a power on the outside, so we're going to start by bringing that to the front. So we have 5 log of 7, log base 7 of x times y to the 6th power. Now since we're multiplying these two things on the inside the parentheses, to break it up we need to add them. So we have 5 log base 7 of x plus 5 log base 7 of y to the 6th power. And now since we still have an exponent, we need to bring this to the front, but we already have a number there, so we're just going to multiply the two numbers together. So again, we have 5 log base 7 of x plus, now we multiply the 5 and the 6, so we get 30 log base 7 of y. Any questions here? All right, 23. So in our parentheses, we're multiplying everything together, so to break it up, we need to add them. So we have log base 9 of x plus log base 9 of y plus log base 9 of z to the 5th power. Now we're going to bring this 5 to the front, so 5 log base 9 of z. Any questions here? All right, 24. Okay, so we're multiplying everything inside the parentheses, but if we take a look at it closer, the 3 and the 7 are both under this square root. So to get rid of the square root, this is the same thing as saying 3 raised to the 1/3 and 7 raised to the 1/3. And we raise both of them to the 1/3 because they're both under the cubed root. So now we have log base 6 of 5 plus log base 6 of 3 to the 1/3 plus log base 6 of 7 to the 1/3. And now we just need to bring our exponents to the front. So we have log base 6 of 5 plus 1/3 log base 6 of 3 plus 1/3 log base 6 of 7. Any questions here? No questions on expanding logs? All right, 25. So there's just going to be one question that you have to use your calculator for logs. So we need to do our change of base formula. So we're going to the log of 4. Next, we need to find out what both of these are, so we're going to put them into our calculator. Make sure you guys know how to use your calculator for the test tomorrow. So the log of 22 is 1.3424. And then the log of 4 is 0.60206. And now we just divide these two together. And we get 2.22. So 2.22, let's see, it says to the nearest thousandth, so it's going to be 3 decimal places. So 2.229. Any questions here? Okay, last one. So we're going to have log of 10 on top and log of 2 on the bottom. So we need to find out what our log of 10 is. So our log of 10 is just 1. And then the log of 2 is 0.301029. And now we just divide those two. So we have 1 divided by 0.301029. And we get 3.32, and I'm going to round it to 2. And this is our answer. So for the one question like these on the test, I am like 95% sure it says round to the nearest hundredth, which is just 2 decimal places.